guitar if I go use the little boy's room?
Be quick. We got 2 minutes.
Oh, I ain't gonna be making 2 minutes already too.
One of those. Gotcha. All right, let me see your homework. I'm going to check it really quickly. Does anyone have their outlines to turn in? I'm going to be giving feedback on those during this period.
Oh my goodness, it is cold.
Yeah? You think so?
Yes, I think so.
Where's your slope in there?
She's in there somewhere.
You need to indicate your slope. You can't just like randomly put crap.
I didn't randomly put crap.
So then how do you know that that line is correct?
I don't know.
If you do not indicate clear slope, you cannot say that that is completely correct. When you get all salty about it, I'm trying to help you to, make sure you don't make these mistakes on tests and quizzes. Because that will hurt you a lot.
Well, that was
Nice. That was nice.
So I'm gonna pull out 4.1. Check homework.
I think I did the right questions. I would believe so. Yeah, you show some work here. And Cal, it's more for tonight because there'll be an accuracy check that involves number 6 and one of the others. So you want to make sure that you indicate those different details. Brianna, go ahead and get out that 4.1 because we're going to go over that.
Oh, it's recording. I didn't know.
Mm-hmm.
I was like, when did you not pass that?
Good job on indicating those things. That was good. You want sure on that one? Okay. Hey, really quickly, let's go ahead and tell them to fix 21. Remember that's where it says b equals 5 and it should be x equals 5? Okay. So make sure you ask a question about that, okay? Okay. Let's get a straight edge or something to make sure you're doing a nice clean one, okay?
So don't have 4.1 out. Just check the homework.
You want to let us say to that one either? Don't forget, y'all, we need clear justification on all these problems to indicate why you think what you do. All right, Tina, start going.
Anything specific that you saw that we need to talk about?
Definitely talking through at least one of the graphs and talk through number 20.
20. Okay.
All the bathrooms upstairs are locked.
For real?
Yeah.
Go downstairs, if it's that bad. Really quick point of order, does anyone have their outline to turn in? Because I'm going to be giving you feedback on it in class today while Mr. Lipton teaches.
Yeah.
You have your outline? Can I see it?
No.
I mean, I would assume you want feedback.
You better check my home.
I already did it, didn't I? Make sure you use the straight edge to get to those points, okay?
I tried doing my folder or whatever to make it straighter.
If you need to, come by in the morning and grab a ruler and do it quickly. Yeah, definitely go over number 20.
Okay.
Not just you, everyone.
So one thing before we start talking about this, I want y'all to look at Go number 21, because this is important since this is for accuracy. I'm pretty sure it says B equals, but it should say X equals. Is that right?
Yeah, number 21 is that B equals 5, it should be X equals 5.
So just make sure you have that, because that's going to be for accuracy tonight. So let's go ahead, since it sounds like there's a lot of problems with 20, let's go and look at 20, and then see if we have any questions on the graphs. So for number 20, first I guess we should talk about what does it mean when it's asking whether W equals 1/4 is a solution or not. It's kind of something we talked about on Monday. So what does it mean when we say if something is a solution or not?
I'm so sorry. I did not mean
There you go.
What was it? It was something like Like, it's not like, I don't know, like, it's not like answering, but like, it's like, no, I don't know.
It's similar to an answer, but not quite, because an answer can be incorrect, right?
It's true, true.
It's true, so it makes, in this situation, if it's a solution, it makes our equation true. So that's that key word is true. So if we have w equals 1/4, what we need to do is substitute 1/4 in for w. So we had ended up with 4 times 1/4 because we substituted in for w, and then 1/4 plus 3/4. Now, did we understand that we needed to substitute w in up to this point? Is that what we had problems with, or did we have procedural problems once we got to this point?
It felt like they saw a fraction and they freaked out.
Freaked out? That's
Is that what
understandable. So
I just put a,
You what?
I just didn't use,
Why not?
yeah, because I forgot about it.
Okay.
So, first step is always to substitute this, and then we see a fraction, so if we're obviously in class, we can use a calculator. Even if you're at home, you can, if you have a calculator on your phone, or there's a calculator on, Desmos, SimiLab, all those have pretty simple calculators if you aren't sure how to do this. But if you are, you're looking at 4 times 1/4, this is the same as, you have a 4 divided by 1 times a 1/4. Those 4s will cancel out to get you 1, if you are unsure how to multiply that. And then on this side, 1/4 plus 3/4, so remember when you're adding fractions, if they're the same base, you just add the numerator. So that's also 4/4, which equals 1. So that's how we get to this 1 is equal to 1. Now is that 1, is 1 always equal 1? Is that always true? Yes, right? So whenever we get to this point and it's true, that's when we know that w equals 1/4 is a solution. So I have these, I've written out these terms, and we'll talk about the other two during the lesson, but I would recommend writing these terms down, and whenever I fill out these definitions, to take notes on them, whether on a piece of paper or on your 4.1. But since we've already talked about this, a solution, especially when we're talking about equations, is a value that makes the equation true. And what we're looking at right now. So wherever you have space for that, I would write that down. The key part is that it makes it true. So wherever you have room for that, I'd suggest writing that down, just because as we're going through this, I know that, that's so slanted. I know that sometimes it's hard to remember all these different, terms and definitions if we haven't, fully learned them yet. So it's good to always have them for reference for when we're unsure. So what we're talking about now, a solution, this isn't necessarily the only definition for a solution, but we're looking at equations. A solution is a value that's making that equation true. So I also heard that we should talk about one of these graphs. Did we have a specific question on how to do these before I walk through probably number 5? So it's a little harder. Also, okay, we're looking at homework right now, and I'll suggest writing that definition for solution down on somewhere in your paper. So if we don't have any specific questions, I'll just kind of walk through again. Well, we're going to look at number 5. So looking at this one, we know that it's in slope-intercept form, so y equals mx plus b. So what do we think? If we know it's in y equals mx plus b, or slope-intercept form, where do we think we should start? What should we do first? Alan, what do you think? I have y equals 5 halves x minus 7. Where do you think I should start to graph this?
Hold on, let me do that again, I'm sorry.
So look at number 5. We have this equation, and we know it's in y equals mx plus b, or slope-intercept form. Where do you think we should start to graph this equation? So you're saying up to, so at -7, y -7. What is, I should ask what is -7? Y-intercept, good. So right here, There's our y-intercept, we plot that point, and then now we can look at the slope. So our slope is 5 divided by 2. So which direction is that slope going? What's our rise, what's our run?
Up 5 over
Up 5, and then which way 2?
The right two.
Right 2.
Right.
Then what you can do from there is take a straight edge, ruler, piece of paper, something that has straight edge, and draw that line through those points. And you could also make more points, so just keep going up 5 to the right 2. So then it asks, is the point 2 negative 2 a solution? How can we see if that's a solution or not? How can we see if that makes that equation true?
2. It's on the graph.
Yeah.
It's on the graph. Where on the graph?
Like, it's on the
The
line.
points.
So it has to be on the line, right? So see right here is where he circled, this is where that point is, so it is a solution. Now, if you don't want to do that, you could also substitute it in to the equation, kind of like we did for 20, to see if it's true. Are there any questions on that? Because now is the time to ask, since tomorrow is an accuracy check. So if there are any questions on how we did that, fire away before we jump into 4.1.
How did you get so many points on number 4? It's only got 2.
So you technically only need 2 points to create that line, but sometimes it helps you to plot more points just to more accurately plot the line. So here, I think you start with this point right here, and so then you know your slope is 1. So up 1 to the right 1, up 1 to the right 1. So I typically like to do 3 or 4, but you can do this many. You can technically do 2, but sometimes it can lead to some inaccuracies. So I would suggest at least plotting 3 or 4 points to then help you make that line.
As long as you got the points, the 2 points where they're supposed to be, and you don't add extra, it's like, it's still wrong.
So I'll tell you, if you have 2 correct points and it's going through the line, and the line is accurate for the rest of the graph, you'll get it right. But I have personally done this where I might plot these 2 points, but then later on, the line might start to taper off one way or the other, and so I'd get it wrong. So that's more of you only technically need 2 points to create that line, but it's more of just if you want to make sure that you get it right, especially for one that you know exactly how to do, the more points you have, the safer it is. So it's up to you. That's a good question. Any more questions?
I will say this, just for the grading side of things, because I think Ms. Logan hit this great, but you see on number 5, when we had a slope of 5 halves, so I went up 5 and to the right 2. 4 points took up the entire graph, and it made it very accurate for my line. If I just did 4 points going up 1 and to the right 1 with number 4, it would not have taken up much of that graph. And so the more points you have, the more accurate it is. But I will say, like Mona, if you had taken a ruler through those 2 points and made sure it was super accurate, you would have gotten it right. But the more points you have, the more accurate it will be. But because it's a slope of 1, you could go up 1 and to the right 1, or you could even go up 5 and to the right 5. Because what's 5 divided by 5? 1. Right? So you can go by other things than just up 1 and to the right 1. And so that might help you get more further along the line to make sure that line is more accurate. Does that make sense? But we do want accurate functions. We want accurate lines. So hopefully that clarified some details there.
Any other questions?
No, sorry.
Awesome. So, we're gonna now move back into what we were working on yesterday, 4.1. So, taking another look at our objectives. So we're still looking at, we're writing equations that represent some of these real world scenarios, and then solving those equations through using the properties of equality. So who remembers what the properties of equality are? Linnea, do you remember what the properties of equality were that we talked about yesterday?
What you do to one side, you have to do the other.
Exactly. What you do to one side, you have to do the other of an equation. So if you subtract from one side, you have to subtract the same from the other side, so on and so forth. So I wanna talk a little bit more about number 1, just because I felt like maybe we were struggling a little bit with number 2. So if we have a more thorough discussion about number 1, it might help us. So, I wanna look at, so we had two equations, we had, 4x plus 20, or no, it's minus 24 divided by 3 equals 12. We had that equation, then we also had a 4x equals 12 times 3 plus 24. And you might have had a slightly different variable, but as long as you assign that variable, it's fine. So, what did we say about these two equations? Do we remember?
They're equivalent.
They're equivalent. So, if you notice, I have this term up here, equivalent equations. So this is another one we should define and write down. What does it mean when two equations are equivalent?
They're different but equal.
They're different but equal. So kind of, so they two equations that look different. When you say but they're equal, what do you mean?
They equal the same ending.
They have the same ending. What's that key word? They have the same
Solution.
solution. Good.
That makes
So-
it true.
Makes it true. Thank you. There you go. Look different but have the same solution. So now what I'm going to do is I'm going to try to prove that these two equations are equivalent. Because we said they were equivalent, but we didn't really prove it. So I'm going to work through simplifying both these equations and let's see if they end up being equivalent. If I make a mistake, just shout it out. So 4x, so 12 times 3 is 36. We have plus 24. So then we have 4x equals 36 plus 24 is 60. So now here's the first instance where we're using a property of equality. So how can I solve for this x right here to find the solution?
Divide by 4.
Divide by 4. So what do I have to do to the other side?
Divide by 4.
Divide by 4. So that's that property of equality. So then I get x equals 15. Right? That's what we got. So now I want to look at this equation. One thing I did notice that I want to point out, I have it written with this fraction bar. And I think that's how some of you wrote it. But I've also seen some where it's written like 4x minus 24 and then this division symbol like that equals 12. So first off, what are we missing there if we write it like that?
It's parentheses.
Parentheses. So first off we need parentheses like this. So while that is correct, I will tell you, you could run in, I did see some people run into some problems when you write it like this when we get to simplification. So I would suggest writing it this way. Now if you understand this and can solve it correctly using that way, it's correct. I just think it could lead to some potential errors. So I'm going to simplify this one. So what do we need to do? We have this divided by 3. What do we need to do for both sides of this equation? Start simplifying this. What do we think our first step should be?
Multiply by 3.
Okay, so we're going to multiply both sides by 3. So that gives me 12x minus 72 equals 36. No?
Yes.
Yes. Is that right? Alright, so then I can add 72 to both sides. 12x equals, that is 108. And then divide 12.
It's 8.
Is that 8? I think it's a little over 8.
It's
No.
9. So are these two equations equivalent?
No.
Where we got 4.
So you got, what's the difference between how you got 15 and how I got 15? What do you think, which way do you think is correct?
You probably did it right, I probably did it wrong.
So how about this? So I will tell you right now, there is an error, I made an error somewhere, and I would like for someone to find it. I'm not gonna, I would love for someone to find the error that I made.
Got it.
What is it?
You multiply 24 and 4 by 30.
Why can't I do that? We said multiply 3 on both sides. So-
It'd be 4x minus 24 plus, equals 36.
So you're saying here that these threes, what? You're saying I would get
Cancel out.
4x minus 24 is equal to 36, because those cancel. Is that what you're saying? Is everyone, do we agree with that, or do we disagree with that? Yes?
I fully agree.
You agree with yourself, that's good. Anthony, you agree? Alan, Mona, alright, so I wanted to specifically point that out, I did see this error being made both on 1 and 2. If you were multiplying, so if you have this fraction, you're multiplying that side by 3 or whatever it is, that's the inverse, and you're creating an identity right there, and those 3's would cancel, or whatever you're multiplying by would cancel. So then from there, when you solve, plus 24, you get 4x equal to 60, so then
15.
now we've got 15, so now those are equivalent, right? Because we found the same solution. So while there we're looking at equations, I do want to point out real quick before moving on to 2, what do you think the difference between an equivalent equation and equivalent expressions are? What do you think the difference between those two terms is?
Which two equations?
So we defined equivalent equations, but I also have equivalent expressions written up there. What do you think that is? So let me ask this, what is an expression?
The way,
Do we remember?
the form of a solution.
The form of a solution, what do you mean?
The
It's
way it's,
wrote out.
The way it's wrote out. So like, we found the solution x equals 15. Is that an expression? It is?
no, that's a solution.
Okay, that is a solution. What is this? Is this an equation or an expression?
Expression.
Why?
Crap.
Cause it,
So remember,
So you,
right here, this equal sign. Does that mean it's an equation or an expression?
I'm trying to say
equation.
Equation. If we have an equal sign, it's an equation. So what about if I just have 2x plus 2? Is that
that's an
expression.
expression.
There we go. That's an expression. Sometimes you just gotta see it, right?
Gotta say it to believe it.
So, what do you think I mean when I say equivalent expressions?
Their expression,
They're equal. They're different. They're equal without an equal sign.
So two expressions that are different, but what?
But
but
not equal. Or not equal.
They're not equal?
They are equal.
equal.
They are equal, okay, sorry. So like, I just mentioned 2x plus 2, is that equivalent to 2 times x plus 1?
Yes.
So, because then you get, when you distribute,
2x.
2x plus 2 equals, oh, sorry, yeah, 2x plus 2. So while those two look different, right, they're not the exact same, they're equivalent because when you simplify, they end up being equal. So, does that make sense? I know we haven't talked about that a ton, but that's kind of, we're focusing on what being equivalent means in terms of both equations and expressions. Roll tide. All right, any questions on that before we get to number 2? Because I do want to talk about this before we do it in groups with the remaining time. All right, so I do want to go back over this because I think that we might not have understood what this question was asking us to do yesterday. So, first off, it was asking us to look at, we were trying to find how many students were sitting at the front table. So how can we, what do we use when we have a number that we don't know what it is? What do we use to express it? A a variable. So let's just go with X. So, and I did have this question like this step right here, and we have the students at the front table, that'll always be X, or our variable that we decide. Then what we're wanting to do is move through these steps algebraically to see what that's doing to that X, so then at the end we'd have an equation to solve. So I do think most of us got through this. So what do we say for if it doubles the number of students at the table, how do we represent that algebraically?
Multiply times 2.
Multiply times 2, and then we have 4 more, so then what do we do?
Where?
We have 4 more students come in, so
Oh.
add 4. And then it's split into 3 equal groups. So we have our 2x plus 4. And then what happens when it splits into 3 equal groups?
Over.
Divide by 3.
Yeah.
And then how many do we have left at the end? 12. So I'm pretty sure this was, similar to the equation. That was the equation everyone found, or an equivalent equation. So
16.
So you said it was 16. So what it's asking is first, do we think the order matters?
Yes.
Why do we think the order matters?
It is a chronological question in order, and changing the order and change the final answer. And we'll change the final answer.
So it'll change the final answer. Good. So now, did we all get to a point where we found the solution to this equation? Did we all get to that point? So this is where, and this is why I, made that mistake I made earlier, is what should be our first step here? To find the solution.
3.
So multiplying 3. So now what can't I do? I saw a lot of 6x plus 12. That's wrong, right? So those 3's cancel, so then we have, 2x plus 4 is equal to 36. So then we get x equals to 16. So that's why, really, that's why I focused on that on number 1, is we need to become comfortable with, even if we have a fraction, we need to become comfortable with, multiplying it out and being able to solve using those properties of equality. We're going to keep working on that, but that's something we should be getting a little more comfortable with. So this question, I don't know if anyone answered this question how they're supposed to. So rearrange the middle 3 notes in a different order and determine what the new order implies about the number of students seated at the front table at the beginning. So I think I might have had a brief discussion with a couple groups about, like, if you change the order, don't change the final answer. But what we need to do is, if you switch those middle 3 notes, what would the new answer be? So what I want y'all to do in groups is to focus on